Hey guys, Mr. Backerberg here. In this video, we're going to look at evaluating some expressions. Now, before we get too far into things, there are a couple of terms that I want to define. And the first one is variable. In algebra and as you move into higher level math classes, you use variables a lot. And a variable is just a letter that's used to represent some number. Now, the next term I want to define is what an algebraic expression is. That's what this video is all about, is algebraic expressions. So, an algebraic expression consists of numbers combined with variables using some sort of operations. Addition, subtraction, multiplication, division, any of those operations could show up in an algebraic expression. Now, one of the big things about algebraic expressions, and this is very, very important, algebraic expressions do not have an equal sign in them anywhere. So they can have an addition symbol, they could have a multiplication symbol, but you will never ever see an equal sign in an algebraic expression. If you do, then it's not an expression, it's an equation, and we'll deal with those later. Now, down below here, I do have a table full of a bunch of different algebraic expressions. So if we look on the left-hand side, and I'm going to start on the top here, these all represent different kinds of multiplication. So having 5 and then this set of parentheses with an n inside of it. That means 5 times n. So we're taking the number 5 and we're multiplying it by n. But there are different ways to write multiplication. One way is putting a dot in between those. Dot means multiplication, so 5 times n, or we could just write them right next to each other. We don't need to put a dot right between them. So this 5n really means 5 times n. Now, division, if we look down at the next row here, there's really two different ways that you're going to see division. And I'm going to start with this one on the right-hand side. You might see an actual division symbol in there. So this is saying 14 divided by y. But if we look on the left-hand side over here, fractions also mean division. And it's the top thing being divided by the bottom thing. So 14 divided by y, just like we saw with this other expression here. Now, addition, there's really only one way to write addition, and that's with a plus sign between them. So this is saying 6 plus c. That's our addition. And same thing with subtraction. The only way to show subtraction is with a minus sign between them. So this is saying 8 minus x. Now, the title of this video is Evaluating Expressions, so that's what we're going to start doing. To evaluate an expression means that we're going to substitute a number in for the variable and then do any simplifying that we're able to do. So in these next few examples that we're going to run through, we're going to evaluate the expression using an n value of 3. So that means anywhere in our expression where we see n, we're going to plug in the number 3. So as we look at this first one, we've got 13 times n, but we're supposed to plug in 3 for that n value. So if we do that, it's going to be 13 times 3. Now when we do this multiplication, this is the simplifying part, we're actually going to multiply these numbers together. 13 times 3 should give us an answer of 39. Now as we look at our next expression here, we're taking 9 and dividing it by n. So if we substitute that 3 in for our n, if we replace the n with a 3, we're going to get 9 divided by 3. And 9 divided by 3, that's going to divide out nicely. We should get an answer of 3. For our next one, we're going to do n minus 1. Again, plugging in that 3 for the n value there, we would get 3 minus 1. And 3 minus 1 is 2. Still plugging in that 3, now our expression says n plus 8. I'm supposed to plug in that 3 for the n value, so this is going to say 3 plus 8, and 3 plus 8 should give us 11. One more example here, we've got 7n. Now there's no operation written there, but since these are written right next to each other, remember that means that we're going to multiply these together, and again, we're plugging in that 3. Now when I write this out, I am going to put the dot in between there, so I'm going to go 7 times 3. Remember, putting the dot in there means the same thing as writing those right next to each other. 7 times 3 should give us an answer of 21. Now there are other operations aside from just addition, subtraction, multiplication, and division. And the next one that we're going to talk about is an exponent. And another name for an exponent is a power. And what exponents and powers really mean is repeated multiplication of the exact same factor. So sometimes you might see something written with like a big 3 and then a little 4 up above that. That's an example of using an exponent or a power. Now there is a little bit of vocab that goes along with our exponents or powers. The 3 down here, that is called the base, and the 4 up at the top here, that's the power or the exponent. Now, what does this really mean? I said powers and exponents meant that there was repeated multiplication of the exact same factor. So having 3 with a 4th power on it really means that we're taking 3 and multiplying it by itself 4 times. So it's saying 3 times 3 times 3 times 3. That's what 3 to the 4th power means. Now, if we were to simplify this down to try to get ourselves an answer here, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So a shorter way to write that, instead of writing out all of this multiplication, that's why we use powers to shorten that writing. So we could say that 3 to the 4th power equals 81. Now, there are a couple of powers that have special names. So, for example, if you saw something with like an x with a little 2 above there, the little 2 power means squared. So we would read this as x squared. Also, if you saw something with a power of 3, so say it was x being raised to the 3rd power, the 3rd power is called a cubed power. So we would read this as x cubed. Generally, other powers don't have special names. It's just a power of 2, which we called the squared, and the power of 3, which we called cubed. Anything bigger than that, like this 4th power, we would just say 3 to the 4th power. Or if there was a 7, we could read it as x to the 7th power. Now, the next thing we're going to do is look at evaluating some expressions using a calculator. And we're going to look at expressions that have powers. So, for example, here we've got the expression k squared. And we want to evaluate this when we're dealing with a k value of 2.5. So that means we're supposed to plug in 2.5 for the k value. So this is going to say 2.5 squared. Now, on your calculator, and I know mine might look a little bit different than yours, somewhere on your calculator, mine is right here, we probably have a button that says x squared. So if I want to evaluate 2.5 squared, what I'm going to do first is type in 2.5, and then I'm going to hit that x squared button. And you can see on my calculator, it puts that little squared power up above the 2.5. Now, if I hit enter or equals, it's going to tell me that the answer is 6.25. Now, as I go down to the next example here, we're going to do x cubed when our x value is 8. So again, we're going to replace the x with 8. So we're going to have 8 cubed. Now, on my calculator, I don't have a button with a cubed power on it. So I need to look for a different button. And I'm looking over here on the right-hand side of my calculator, this arrow pointing up. That's called a caret. Now, yours might be in a little bit of a different location, but you should have a button somewhere with this arrow pointing up. So if I want to do 8 to the 3rd power, or 8 cubed, what I'm going to do is I'm going to hit 8, then I'm going to hit my caret button, and then I'm going to type in 3 for my power. Now, my calculator raises the 3 up as an exponent. Yours might just put the actual caret between the 8 and the 3, so you might see it written on your calculator as 8 caret 3. That means the exact same thing as 8 cubed. So when I hit enter, I get an answer of 512. Now we're going to do one more here. And we're going to take d to the fourth power when d is 2/3. So if I replace the d with 2/3, this is going to say 2/3 being raised to the fourth power. Now you have to be a little bit careful when you're dealing with fractions and putting them into the calculator. Remember, this fraction bar means divided by, but what we need to use are some parentheses to help us out. So before I type in my 2 divided by 3, I'm going to use a set of parentheses. So I'm going to do a left parenthesis, then I'm going to do 2 divided by 3, because remember, 2 over 3 means 2 divided by 3. Then I'm going to close my parentheses with a right parenthesis. Now I need a fourth power, so I'm going to have to use that caret button again. So I'm going to go caret 4. So this is saying 2/3 raised to the fourth power. When I hit enter, I get this big long decimal as my answer. Now we're going to wrap things up with a word problem here. So it says the cost of filling a car's gas tank can be represented by the expression xy. Now remember, if there's no operation written between them, that means multiplication. So xy really means x times y. Now x is going to represent the price per gallon of gas, and y is going to represent the number of gallons that we're buying. So let's say you purchase 10 gallons of gas and the price is $2.35 per gallon. We want to find the total cost. So I'm going to write this out. Our expression was xy, and remember there's nothing written between there, so that means multiplication. I'm actually going to put the dot in between them so that we remember that it's multiplying, so x times y. Now we said x represented the price per gallon of gas, and down below we were told that the price per gallon was $2.35. So I'm going to replace the x with $2.35. So 2.35 times, we said the y value represented the number of gallons that we were buying, and it said that we bought 10 gallons. So I'm going to replace the y here with 10. So in order to figure out the total cost of the gas, we need to take 2.35 times 10. And if we go ahead and do that, we should get 23.5. Now I'm going to have you adjust this answer just a little bit. There's context to this problem. This doesn't just mean 23.5. We're talking about money here. So this really represents a dollar amount. So I need to make sure that I'm labeling my answer appropriately. So I got to put a dollar symbol in here. Then money usually has 2 decimals. So I'm not just going to write it as 0.5. I'm going to write it as 23.50. So the total cost is $23.50. That's going to be it for this video. Thanks for watching.